Hello, how are you? Good morning, good afternoon, good evening. To start, let's go for our cup of coffee that cannot be missed. I will do S, and I hope it is as clear as possible. In the previous episode, we were reviewing a series of rules for integrating, and we saw the simplest rule, which is the chain rule. We saw different points we had to take into account in order to have and be able to solve an integral in the simplest and most simple way possible. Efficient in this case, the previous exercise did not allow it. Today we will see another example related to chain rule. What would happen if we had an integral of x like the previous class, the previous episode, but in this case we should have x to the cube multiplied by dx. Let's copy this one again to be able to annotate them as in the previous episode, and in this case it is exactly the same. We commented on the previous class. The previous episode that there were certain elements that we had to have in order to resolve the integral. We see, for example, that we count with a u. We have a u and a day you need to count on them. We see in this exercise that our u is going to be the x to the cube part, and our du, let's see if it matches that. It is of x. Nothing more perfect. Our u, we had discovered that it is the part of the integrating, or the part that we will independently integrate of the exponent. That is, that if it is clear, our u, in this case, it would be x, which is what we want to integrate. Leaving out the exponent, and our du would have to be the derivative of that x. Our derivative of x is dx perfect in this case. In this case, we would have u and the derivative of u, which is dx. We check and make a series to see if we can integrate. We see that we have dx, correct? We do have it. We checked our u, which is our x. We do have it. In this case, I am going to shade them here with another color to be a little clearer about what I mean by the u. This part, I'm locking up purple color in our u, and all that is left over, everything else that we did with that integrating in our du. In this case, it would be dx. If we can observe, we have both our u and the derivative of the same u, which is dx perfect in this case by obtaining already within the integral these elements. Is possible and viable to continue with the integration part. We had seen that the simplest rule was the rule of the network that we explained in the previous episode. We saw that this chain rule had a certain format or a certain formula that told us u to the n plus 1 and n plus 1. We can see that we already have a du. We can ask ourselves again, what is our n? And I ask you, when we are going to solve that, we have already gone through the process of making the delicious to review. If we have all the elements to be able to integrate, we see that we have a du. Now we proceed to the method, which is the rule of the chain. Now in this case, at the time of integration, it is necessary for us to use everything we have to integrate. In this case, it would be all this, the x to the cube. Now yes to the cube, together with the dx, we already know what is the differential of our u, our du, then viewing now. Yes, to apply the formula that our u is x to the cube, our n would be 3. We are now, yes, I understand, evaluated that we can use the chain rule because we have the full differential remembering, and I will write them on this side, that the differential is equal to the derivative within the integral and must be complete. Derived from what? Of our u, excellent. We then went on to apply the formula, which would be simply, we record and replace the data we have. We have that our u, which is x, our n, which is worth 3. We add 1 because that tells us the format of the chain rule. I will put one more rule, one stripe straighter and below n, which is 3 plus 1. This would still fit us x to the 4th out of 4. And we had said the previous class or the previous episode, which was more the constant integration of integration that we exemplify as a c, that c should always be in the integrals. And this would be the answer or the solution to the integral we had here in the beginning, c. I will proceed to delete this part to leave you with a series of exercises in which in the following episode, let's solve together. And if you have any questions, please write in the comments below and we are happy to solve them. I am going to place you in this part upper, right? The part of the formula, the string rule formula, which is u to the n plus 1 in n plus 1. Now, what if we had an exercise that it was maybe x to the 5th dx? What happens if we had an integral from x to the 5th minus 4 of x? What would happen if we had an integral of 2x squared for your dx? Of course, I leave you with these 3 exercises for you to try to solve them. We are now seeing the chain rule y, which is the simplest we have spoken of, the universal rule that is always tried to make it simpler to solve a problem. Not necessary. Complicate ourselves with a more elaborate method if the exercise is solved with a simpler method. In this case, making as a count, we always need a u, and from that u we are going to get a du. Always this du, it must be complete. And here, complete must be a complete reference to our u of u is the derivative of u, and must be complete with. In the following episodes, we will see in the event that it is not complete what we can do, how can we add it, and if we can follow us on the road of the chain rule, or we have to use another salt method. This is how we are going to leave this episode. Thank you very much for watching the video. If you have any comments, please write at the bottom. At the bottom of the video is coming information where they do need any advice or tutoring. I am happy to assist you. Thank you very much. Take care of yourselves and see you in the next episode.